Hello, everyone.
Hello.
Hello, good afternoon.
All right, this live class, we're going to do two things today. We're going to look at the Python for data science, and we're going to look at the programming concept that we use in week one's lesson, which is looking at the type hints and return values, summarizing functions, and we know the different built-in functions we have. Look at meta classes and closures, and then the built-in modules we have, and then decorators, and then the JavaScript object notation, and we'll look at the different HTTP requests and API. Now, I'm not going to repeat what we already have in the pre-recorded videos, and so you want to go back to the videos to look at these summaries of all of these topics, and we're going to focus majorly on the things that we did not elaborate on in the pre-recorded video, which is mostly the JavaScript object notation and the HTTP request, and we will build a mini API in this class. And then we'll move on to data structures and algorithm, and we will use the things we learned in week 12 for solving the shortest path problems in the graph data structure, and we're going to build a city emergency response network where we want to build an emergency response system that connects hospitals and police stations and fire stations and rescue centers with emergency helipad also. And we're going to do this using different ways, looking at response time, and we'll plan the infrastructure and upgrades, and we'll detect risky cyclic routes, which is very important when you are designing emergency response. And the cyclic routes, we'll talk about cycles previously, and we did not elaborate why it is important to detect cycles, because when you do like emergency response, you want to look at the parts that have high vehicle traffics. Those are the cyclic routes. They have poor road surfaces or potholes, constructions, narrow lanes, maybe steep drops, dangerous intersections, or features like streetcar tracks and narrow shoulders, things like that. And those are the things that we're going to try to detect when we build that. So we'll start with the Python for data science, and we'll start with building an API, and we'll get a case scenario for what we want to build. Let's say for this live class, we want to build something close to the assignment so that you easily understand how to work with the assignment. So we're going to try to build something that we will interact with a public API, and we'll try to create maybe a file, we'll load some information, we'll try to manipulate that file. Maybe we'll do something like student records, something like that. So we're going to decide as we go along. All right. So the first thing we're going to see is, well, before I start, does anyone have questions from the pre-recorded video before I start elaborating?
No.
No, nothing for now.
Okay. All right. So we have what we call the GET request. The GET request will request data from a server. It doesn't modify anything. It just gets data. It's whenever you repeat the same request, you get the same result. And when you get this, use this GET request, the data is in the URL. Now, let's say you have an API. You use GET. So this is how you normally see things like this. You see GET, and then you see maybe the link to the API, and then maybe you want to get, let's say it's a student site and students. So you see something like this, the link and / the route or whatever you use to call that API. So basically you use the GET request to read information. Now we have the POST. Now POST is for you to create data. All right. You send data to the server. You create a new resource. When you create data, you're creating a new resource, and the data is not in the URL, but in the request body. So the same thing like when you are designing a form in HTML and you use post and get, it is the same concept where if you use get, it is in the URL, it's not secured, you can bookmark, and if you use post for secure data, and so you write post like this, then API students, something like that, and then the request body, it will have all of the data. So anytime you use get, you read information, you use post, you create something new. We have another one, put, which we use to update or replace data. So when you have an existing resource, you replace it completely or you update the object. All right. So use put, and let's say you want to put students and the one that the ID is 1 or something like that. We'll build an API and you know what this means. So it's used to fully update. Then we have something we call patch. So when you use put, you fully update. But if you want to partially update, you use patch. Okay. So when you use the patch request, you update only specific fields in the data. We have delete, where you used to remove data. Now we see the HTTP methods that we are going to use. We have status code. We have 200. When your status code is 200, it means that it's okay, connection is successful, whatever you want. When you see status code 201, it means that you have whatever created. All right. When you see status code 400, you see bad, it means bad request. And then when you see 404, everybody knows 404, not found. So when you go to a 404 page, it means that it's not found. And when you see 500, it means you have a server error. Okay, so you have this status code in mind and you know the meaning of them. So we have different API practice links that we can use to practice. And we're going to use one of those links to try to get requests or practice all of this here. In the Python module, we have a request module to make it easier. We have requests, right? And in the pre-recorded video, we install requests. So you can pip install requests if you don't have it after creating your virtual environment. And then when you have the request created in your virtual environment, you then use them. So you can say request.get for get, request.post for post, request.put for when you want to update. Then you can do request.delete when you want to delete and stuff like that. So the first thing you do is to import request if you have it already installed. So let's see that. So we install request. Before you start doing pip install here, as we looked at in the pre-recorded video, you want to have a virtual environment created. Now I'm going to create a virtual environment here so that we don't have to do things system-wide, or we don't have things that we install that will interfere with other apps you have on your system. So I'm going to start with, let me say Python, sorry here, Python 3, venv. I want the name of my virtual environment to be .venv. It's always a convention to put a dot in front of files like this so that you can always exclude them when you push your files to a repository or things like that. So I created the virtual environment.venv here, and then I will activate my environment. So in order to solve any permissions problem, if you're not logged in as an admin, you put a dot first, and then the name of your virtual environment, and mine is .venv. So it's not venv, so I'll say dot, okay, so I'll say ./venv/bin/activate. All right. And so it's activated and you see it in parentheses. So for Windows, it might be script, your name of a virtual environment /script/activate.bat or /activate.ps1 or something like that. Those using Windows system. All right. So when you have it activated and you have your environment in parentheses, you can now start installing. So I can say pip install request. And so it's going to install request in my virtual environment. Does anyone have any question?
No.
So in your assignment 1, you were asked to create an API request function. You were asked to extract titles function to create a function that accepts the JSON data and return only the titles of as a list of strings. He asked to filter by the user ID and to add error handling to it to create a main function for execution. And we also have the expected behaviors for you to see. So we're going to create something similar to help you understand what we did in the pre-recorded video. Let's create a sample JSON file. I'm going to come here and create, let's say I create a file called students.json. JSON is very easy, and the reason we use JSON is because it is the most widely used accepted exchange format for all language. Any language you can use JSON. The JavaScript object notation is the same thing as dictionary in Python, and it fits different data types in different languages. In JavaScript, the object type that we use is just the same thing like the Python dictionaries, except that when you have the key in JSON, it must be double quoted. You can't use single or double quotes when you're putting the string. It has to be double quoted. So we'll create a JSON file, and let's put this to be a list of dictionaries. Let's say we want to have two, or not a list of dictionaries, but a list of objects, right? And so let's have two different objects here. This one is ID, and the value is, let's say 1. Let's have, maybe we'll have name, and the value is, let's use Alice. Let's have age, and the value is 20. And then let's have maybe the major, and let's say the value is computer science. Then for this one, let's have another student. Let's put this ID to be 2. I'll just copy this and change the values, make it easier. Then let's have the name to be Bob. We have the age of Bob to be, let's make him 22. And let's say the major is, let's just put engineering. Then I think we should stop here. Let's just have 2 as an example, and then we'll use an external resource to work on this. So we have this. This is how a JSON file will look. And then you can now use this. You can load this file, this local file, and we want to use this file as an example. What we want to do here is, let's be able to use this file to, maybe we'll read information from this, use it to update or send to a public API. We have public APIs. Let's see what we have. I'll check what we have. Public API. Let's look at the URL. Hold on. I don't think you can see my screen. Oh, looking for a public URL. Okay, so I've found one, which is I'm going to show you this. I'll stop share and reshare my screen so you can see that screen. Okay. Can you see the other screen now?
Yes.
Okay.
Yes.
So we can see this public URL, JSON placeholder.ibcode.com/users. And look at what it has, the information it has here. We want to use this to want to work with this public URL to do something. So let me copy this URL and we're going to use it in our code. So here we have this students.json. Let's come here and say we want to we'll import JSON. So if not read about the JSON module and the request module, it is something you need to read about and see all of the methods you have in those modules. And we want to create let's say we'll create the local file variable here. And the local file that we want is the students.json. Now we want to create the API URL. And the API URL is going to be that URL that we want to work with. All right. Now, what we want to achieve here is to just try to use the different HTTP methods and see how we can also use the status codes. We have a local file that we want to use data from, and we also have the API URL, the API we want to interact with. All right. So in the future, when you create your API, users will always have the URL. And if you have an API that have API keys or so, and this is the point where from your environment file or with your secrets file, the API, the API token or whatever you need to authenticate to the API will now check that file for your um, access and then give you access to the API URL. So you have things like in your environment file, maybe you read from a settings file, you can now have things like API URL is equal to settings dot something. Okay. So now let's create a function that will load the local file. All right. I'm not going to use return values in this example because it will be like solving your whole assignment problem. So I'm going to do it in plain, not production ready. And I want you to be the one to do all of the return types and what you need to do. So we want to have a function. Let's say let's form what we want to do. Let me write this. We want to first of all create a function to filter the API users by let's see what we want to filter by. Let's say I want to filter by city. Let's say city because more than one person can have the same city so that we can see the filter working well. So let's say we filter this API by city. So I want to filter API users by city. Then we want to also, in this student field that we have, we want to add a GPA field here to this our student field. Okay, our student file. Add GPA to student.json. And then we want to prevent duplicate names. We want to save API users into a new file. Okay, let's say We'll save. Let's say the file name will be API users.json. So we'll save it to this new file. And we want to write a function to calculate the average age of the students. So let's say calculate average age of students. And we want to add error handling. I think this is part of your assignment too. I'm trying to cover all the topics in the assignment. And let's ask for user input before adding new students. Okay, so let's stop here. Let's do all of this. All right, so now we have imported requests. We've imported JSON. We have the link to the local file we have here and a link to the public API that we want to work with. The first thing we want to do is to filter API by users. But before we do that, let's create local functions that we want to use, like how we can load this local data, this local file, for a function that can do that. And we can create a helper function that will help us to save users to a new file, right? And can also create a function that we can use to add students. So sometimes when you look at what you need to do here, you can use helper functions to make it easier. And it's in these helper functions that you also do your return types that are expected to make it easier to work. So let's say we're creating a function. Let's call this function load local data. And we want to put error handling from the beginning. And so we'll put the try block. In the try block, when we are loading a file, if you go back to your Python fundamental course, you use context manager so that we don't have to be closing. So say with open, and what we want to open is the local file, right? So with open local file, we're opening in read mode. Let's say has file. We want to return the file. We want to load the file. So return json.load, right? And then we load that file, right? And if that doesn't happen, so we use the except block. Maybe the file doesn't exist. You can return an empty list or something like that. So in this except block, you can accept an error, inbuilt error, or the kind of error you expect, maybe 4.1 or something. So now let's write another function. So here you put all your return values and all your expected stuff that you need to do. Okay. So we'll say def save local. Let's say save local data. Let's call it save local data. And we have to pass in the data we want to save, right? And we'll open a file in write mode, and then we will dump. So JSON.dump is what we use to write to a file. So we'll say with open, so we'll open file, or let's just call it local file. So with open local file, write, we'll just do this as file too, just keep the same alias. We'll use JSON.dump. We're going to dump the data and the file. And maybe let's put an indentation. Let's say indent equal to 4, just to format it well. Now, another thing we want to do is so every time you have any create, read, update, delete, you might just create helper function that you always call to do that. So we have add. So we've done add GPA, add error, well, error handling is added. So add GPA, we want to save to a local file, and we want to add local students, right? So let's just create a function for addition of things. So let's say add local students. Does everyone understand what I'm trying to do?
Yes.
Yes.
Okay. So when you want to add students, who can tell me what we can do to make it easy to just add a student? Especially you're adding from a file. Let's say we have a students.json, this student.json file. That's what we want to add here.
Um, Maybe import from students.json.
Yeah, import from students.json, but how can we do it simpler? Instead of writing the whole, open the file and read the file from the students.json, what can we do here?
Um, I'm not sure.
Anybody? So here you can see that we have a load local data function here. So here you can just use that function and just say load local data, because now it is going to take the local file, pass it here, it's going to read it and return the file loaded. So you don't now have to repeat it here. You just use the function. So you see how helper functions are useful.
Yeah.
Now, we say we expect to ask the user for input before adding new students, right? So we can use, what function do we use to now ask for input?
Impute function.
Yes. So let's say name is equal to input, and we want to say enter. Let's see what we have here. We have name, age, major, and we want to add, in the question, we want to add GPA also. Add GPA to student.json. Okay, so we have name, age, major. We'll also ask for GPA. All right. And then for us to have an ID, we want to just auto increment this ID. So let's see how we do that here. So we'll say for the name, we want to ask the user to enter name, right? And then when the name is entered, you want to ask for the age also. And because anything you use from the input function will return as a string, and age you want it to be an int, you can cast your response from here and say input, and now you can now put enter age. Then also you can, let's do the major first. We'll say major is equal to input, enter major, and then we want to add GPA to it. And GPA is going to be a float, a decimal point, so you can cast it one time. Float, input, enter GPA. Okay. So while we're adding these local students, what we want to do here, we say we want to prevent duplicate names. So is it right that we put it in this function where we prevent the duplicate names in this function, or we want to create a different helper function to do that, or we want to create this, load the file and remove the duplicates? What do you think would be the best to do?
I think we should create a helper function for that.
Okay. Who else thinks we should do helper function? So we can create a helper function for that, but yeah, Edmond, you raise hand. Is anyone talking? No?
Oh, okay, sorry. Yeah, I was also suggesting the same. I was saying helper function as well.
Okay. Let me tell you something about helper function. A function that you will not use repeatedly doesn't make any sense to be a helper function. Why is that? You just having a function there that you're only using in one place. So why don't you create it in one place? Because we only going to prevent duplicate names when we are adding a student. There is no time when we'll prevent duplicate names again. If we say we just want to prevent more than duplicate names, then we can create prevent duplicate function. So we can run it for every variable, right? But it's just names. So for me, I will just do it here with when I'm adding the students. So I just create like a loop to go through the students in the file. And if the student already exists, just return, they just say the student already exists and return. And if not, you want to now create the auto increment. So now a helper function here will not make sense because if you create a helper function that will go through it, how do you know in advance the names that you are going to pass into this function? The name that the person entered when the add local student is called. While you can solve that problem with the helper function, it's just an unnecessary layer of problem, right? It's doable. So you can actually try that and create a helper function and ask yourself if it's worth the stress or just add an extra 2 lines here and get over with it, right? So now let's say for S in student. So what do we do now?
You check if the name that's the S is in students.
Okay, so we say if S name dot. So where do we get these students from? Is the local data that we loaded, right? So if we check if the name, we just convert it to lower, is equal to the name dot lower. Why do we convert it? So that we can just do a case sensitive search. Both of them are both in lowercase, right? And it will just make everything easy. So if they are there, we just want to print something else, which will be students already exist. But in real world, you're going to use maybe a matriculation number or student's ID number or something. All right. So we say students already exist, and then we return. Okay. And now when you return here, when we function meet a return statement, it just stops terminate. So when you hit this return, that's the end. The student already exists and it stops. But in the event that is not the case, you want to, who can tell me the next thing that we'll do here? So you can see within collect ID, we want to auto increment these IDs that we have here. We want to look at the last ID and make the next ID the next. So we say new ID will now be equal to, let's look for the maximum of all the IDs that already exist in the student file. Right, we can use list comprehension to make this easy. So let's say the maximum of, I'll just make all on one line and you can break it down as much as you want. We want to get the ID, right? So we look at the value of the ID here. So we want to look at the ID for S in students like this. So I'm going to do this like this is a list comprehension on its own. I hope I'm not overcomplicating this list comprehension. So what we are doing is that we are getting the ID. We want to say, it's just like you're saying for S in student, yeah, you look at the student's ID. If student's ID, the maximum of the student's ID, you get it, then you add +1 to be the new ID. Okay. So I'll do for S in student. So I'll get this ID. So I'm looping through. So this is just looping through the ID. So you can say for S in students, print S, or for S is students, you put all the IDs in a list and get the maximum of it. That's what this is saying. And then we want to use this. And then when we get this list comprehension, we want to add 1 to each of it, right? And we add 1 if the students exist, if there are values there. So if students, else just 1. Why did I put if students, else 1? Can anybody tell me?
If it
Anybody?
is to
Yeah?
check if it is empty or not, the students.
Yes. To check if it's empty. So if there's nothing in that file, no students in the file, you want to start the ID to be 1. If there's something in the file, just add 1 to it, to the maximum of it. So now you understand?
Yeah.
Yes.
So you can break this down with the logic you have so you don't overcomplicate it with list comprehension, but this just makes it faster than just writing all of it. All right. So now, when you have the ID now, you can now get your new student dictionary. So say new student is equal to, so you're not going to pass your new item because here we have a list and we'll have dictionary of items. So have new students and then we'll put the ID is the new
Uh,
ID.
sorry.
Yes? Yeah?
Yeah, so for this list comprehension, I was thinking before the list comprehension if it's possible to do that with a loop to also increment the ID and add the ID as well.
Yes, you can do that with a loop. So we can say let's do it like this. For I in S ID, well, let's say for for SID in students, right? You see that for SID in students, then you can now say SID plus 1, or let's we can put the if condition. If SID, then you say SID, or we can have like an empty list. So if you want to do this, it will be more complicated. So you want to say student IDs like this, right? Is equal to an empty list. For SID in students, you can now put student IDs dot append SID, right? And then once you have appended it, you want to return student IDs that append SID. So once you have finished appending, you get max. So let's say max IDs is now equal to the max of student IDs, right? And then when you get the maximum of the student IDs, you now say new ID. You say if max ID, then you say new ID is equal to max ID plus 1, else new ID equal to 1. So you see the third process.
Yes, it's a bit complex.
Yeah. But it's easier when you think it like this. So if you cannot do list comprehension, just think it like this. You can use the time function to time and see which one is faster, but I don't think any one will be faster than the other. It's just more about readability for, if you are used to this comprehension, you see that you think about how to do it faster. So now we are getting the marks of the ID. So we're saying for the ID in the student file, we're getting the marks of it. Okay. So when I say SID here, this doesn't still work because SID is not anything. So here you can say for um, students IDs like this in students. Okay, I just use S, but it's supposed to be students IDs instead of S because S in students is just like the loop. So I use S here, but you know it's students you're going to use. Okay, so it makes sense.
Yes, yes, it still makes sense.
I'll comment it out and we'll see if we test it at the end to see where our logic is wrong. But it's easy to get the logic wrong, as I'm sure that we might even have an error here already. So let's get a dictionary of new students. So we'll say ID is new ID. We'll say the name is name. Then we'll say the age is age. And then we'll put the major. Did we even collect the major here? Yeah, to input the major. So say the major is going to be major. And then we'll get the GPA. This will be GPA. All right. So we have this that we'll use as the new student. So we've created this as a function. And then now we're going to append to that student. And then we'll save it to the local file. Okay. So how do we do that? We have the students variable that we created here. And this student variable loads the JSON file. When it loads it converts it to a dictionary. So here, this student variable holds a Python dictionary of students. We are going to append to the student dictionary. And then we are going to now save the data in the student. Does it make sense?
Yes.
So let's say, can tell me why we're using append.
Um,
Who can tell me?
Will you please repeat the question?
Who can tell me why we're using the append method?
because
We are
I
adding it to the existing one.
Yeah, but why
Because
append function?
because we want it to be the last.
Key.
Is it
Last key.
first? Last or first?
I
I
want
think it's
it, I
last.
want it to be at the end of the list.
No, but this is a dictionary. You know, we know when we look at dictionaries in Python fundamental, we don't have an append method for dictionary methods that we have. You want to add to a dictionary or want to update, we don't use append method. We use update. So, but why are we using append?
Because it's a list of dictionary.
Exactly. So because the dictionary value is a list, so we use the append or we can use the extend method of that list to add elements to it. So when you look at student.json, you remember we said this is a list of dictionaries, right? And when we get this here, they convert the JSON. This is JavaScript object, converts the objects to Python dictionary. But this is still a list of dictionaries. So here we use the append method. So you need to pay attention to things like this because you can have a technical interview that tells you to identify what is wrong with the code. And if this was not a list, you will scan through and skim through and you don't even know that what is wrong here is append, because this is not a dictionary method. All right. So because we have a list there, we use students.append. And we have the save local data here. So we open that file, the local file, and then we dump the data in the file. Okay, so we say, now that we've appended it to the new student, this is a new student we want to, now we've appended it to the students. After we loaded it, we've appended it, we want to save the local. So when we're saving local, what happens is this, we already have a list of items here. And so when it's saving the local, and after we add this, if there's already duplicate in the student, it doesn't add it. And so when it was saving this local file, it just dumps it there. So let's say student.append new students, and we have save local data, and we'll put the students now because we want to dump it there. When we're done, let's print something to know that this has been done. So we'll say print, let's say students added successfully. Let's try to test this and see. So let's test this. Let's try to call this function and see if we can append or to create a new student. So we have the function here, add local students, right? Okay, so we'll call add local students. And so when we run this, we have enter name. So let's enter the name. Let's say Andrew. Enter age. Let's say Andrew is 23. The major, Andrew is in civil engineering. And the GPA of Andrew, let's say is 3.75. And then the name new student is not defined. Do you mean new students? So you see where we have an error here. New students here. Okay. So let's run this again. Enter name. Andrew, age 23. Major, we'll say, we used civil engineering before, right? GPA, we use 3.75. Student added successfully. So let's go to the file and see if we added Andrew. So yes, Andrew added as the third student. So he's working fine. All right, so this is working perfectly. Does anyone have a question before we go further into other functions here?
No.
But is it understandable or I should repeat it again?
Maybe just one more time.
Okay, so this is the method I thought about and I did this. When you write your code, you can write it as easy as you think about it. You don't have to make it perfect the first time. So I created a helper function to load local data. I created a function to save local data. You can decide not to do these functions, helper functions, and you just go to do everything within this, and then you start breaking what you need can break. Like Choma suggested, we could do this check in a function by itself. Now we can do it here. So you try to see what makes sense and you start breaking them out. When you go to file handling lesson in Python, fundamental course we did, you will know how to use context managers and you know how to open a file in the different modes. We also looked at the JSON module in the same Python fundamental and the different method from the module that we can use to load a JSON file to be able to convert back to a JSON from Python dictionary and what happens when we change them. All right. So we're trying to just use error handling here for you to see to make your assignments easier. We open the file here and we return. When the file is open, return the file. Then we created a helper function that will help us to load the data. And we open the file in write mode. So when you don't have it in write mode, you cannot write to the file. Why I use indent for here is just to have like this indentation. So indentation here. Okay, because we know it's always 4 spaces for indentation in by the default. So we do indent 4 so that it can indent this. So it will be looking nice. That's why we put this, but it's not necessary. You can put indent 6, the indentation will be different. Then, so that every time we want to save a file, this function is called. Then we now have a main function to add local students. So you can always do only this main function to add local students. Then you say student is equal to, then you can now open the file and open the file here, and you put a variable is equal to json.load file, right? Or you just put that as a function and call the function, and the function is going to open and do that. Why do we do this and we put a try except block here? It's because opening a file has a probability of failing. So when you use the try block, you always put things that might fail. And don't worry about the next class of the City Emergency Response Network. If we don't have enough time to do it today, we'll do it on Monday. But let's get this one right for this class, okay?
Okay.
Yeah. So we'll take our time to explain it in details, and then we'll fix another class for Monday to continue the second scenario. Okay. So we created this function. So you can think about it any way you want and do it in a different way. You just want your code to be readable and maintainable. When we create helper functions, we know that we always call this function not only for this purpose to add local students, but always to open any file at all. And in the future, when we want to open a file and we change the name, this variable just holds this. We write it in uppercase that just so that it just looks like a constant, or it's just a convention thing. And then we'll put the public URL that we want to work with. We want to use this file and also work with this public URL there. And in the public URL, we have this, all these things are here. And we have several URLs like that. So I can leave a link on the classroom for Python for data science to have different practice APIs online where you don't need API keys you can work with. Now we did that and we want to add local student. When we just put the variable local students, we want to add it to local file. So we loaded the data, we saved it in students. So when we open the file, it is saved in students. Now this becomes a Python dictionary. The objects, the JavaScript objects are converted to dictionaries here, but it's still going to be a list because Python has a list. So a list of dictionaries. Now we use a user input to collect the data we want. Now in real world scenario, we're not using input. We're not doing a command line interaction. We're going to have a form. So you have a form on the interface that the user or admin will click to add students. And then you have the name field, age field, major field, and somebody will fill the form. And so what this will do now is to say name is equal to collect what was filled in the input field, right? So collect what was filled there. Now, once all of this is entered, you want to focus on the name. And you want to check this student file that has been loaded. You want to loop through. So if you look at the list, when we did list in, I think it's in week 3 of Python fundamental, you'll see how we loop through a list. So say for S in students, now we come to this and we enter this list. So we now want to get the ID from each of the ID key from each of the dictionaries here. So we want to say this is index position 0 is a dictionary of key value pairs. So S is now pointing to 0 the first time, and you get the name key. So if the value stored there, we just use the lower method to convert it to lower and compare it to the name, converting all of them to lower. So if a user use uppercase, mixed case, you just want it to just compare in the same case, right? So we now print students already exist if any of the name is the same. And you return. Once you hit a return, that is the end. This whole thing terminates. It gives you this message and terminates. So you start entering all over again. You can make this a loop where to tell you enter a new name or something, but we just return. So it starts again. Now, we want to get the ID because here we didn't put ID for the student. If you put ID here, this will not be necessary. And we now said we said we are going to test this. So let me comment this out and let's see if this will work. And if it doesn't work, we can now edit it to work so you can think through it. So we want to get the maximum of all of those IDs in this student. And when we get the maximum ID, we want to add 1 to that maximum ID. And if the file is empty, there's nothing in the student list, we want to start it as the ID is 1. So let's run this again and see if this logic works here. So we enter name here. Let's say the name here is Charlie. The age of Charlie, let's say, is 34. Charlie's major is, let's say, chemistry. And Paris GPA, let's say, is 3.45. Now, these indices must be integers or slices, not string. Now, you see where why I say we should test this. Because we have student's ID here. Now, we got this for this in students. For students in, let's see, student's ID is equal to this. For student's ID in students. So list indices must be integers, not slices, or not string. So when we get for student ID in students, the ID is 1. Okay, so the problem we're having with this is that we are getting students and ID. There is no ID variable here. So what we'll do here now, the first thing we'll do is that for S in students, right? Then we'll have an inner loop. Then we'll say or we don't even need to put the inner loop. So let's redo this. So you say for S in students. You know why we're doing this? Does anybody understand why the previous logic was wrong? Because this is a list, right? So when you get into this list, this is index position 0. When you get to index position 0, which is now S, you want to get the ID. So for S in students, we'll say, let's have student IDs dot append S ID, right? So now we say if max student ID, then you say new ID is equal to student IDs plus 1, so it will be max student IDs plus 1, else new ID is equal to 1. So does the logic feel better now?
Yeah.
Yes.
Okay, so now let's run this again. The name here we want to put, let's see, make sure that nothing was inserted here. Yeah, so we need to have a number 4 now. So the new student's name, let's say, is Charlie. The age of Charlie, the major of Charlie, let's say Charlie is a pharmacy major. The GPA of Charlie, let's say 3.65, and added successfully. So you see that this logic is the whole list comprehension. So it's easier for you to think in list comprehension terms, but if it's hard for you to do this comprehension, don't waste your time, just try to do this. But this will take longer execution time because you just append into a list. Every time you look through it, you append first, then you look through what you have appended, okay? But here you just do the loop without appending. Okay, so this will take a longer. So if you want to optimize your code, you change this to that. So when we check here, we can see number 4 now, Charlie 34 pharmacy. Does it make sense?
Yes.
Yes.
Anyone has another question? Okay, now we've done saving into this file. Let's do something else to help with the assignment because we can do the update, we can do delete. Okay, so let's advance this. Now you can translate this into an app where you don't do this once, you just take all of this from what is returned from the front end, from the form input, and then it will run all of this and add it. All right, so I'm going to change this and I'll leave it to use this. Now we want to update the student. Let's say we will get the ID of the student to update. Right, so maybe we'll create a function for this. Let's see. Let's create a function for this. Let's have a function, say def update local student. All right. I'm wondering whether we should continue with this one or we should use request. Now we know how to easily update here. What we'll do with update, I'm not going to go through this. I'll just do it is you load just the same way you do here. You load student is equal to load local data. Yeah, you get that. And then you will get the student's ID. Now, student ID is you cast to an int and have a prompt to enter the student's ID to update. And then you look through the students and you look at the ID of that student, right? If the ID of the student exists there, you want to return that student and you now do another prompt that will tell them to enter the name, enter the age, enter the major, enter the new GPA. Right, so they'll enter all of the values. And if not, you say student not found. The same thing with delete. You do that and then you will look at how to delete from a file. Okay, if you want to display all the students, you can do that. If you want to calculate average age, you can do that. Use that to challenge yourself. Let's move to the request method so that we can do that within the next 40 minutes we have. And then we'll be able to interact with the public API. Now, we want to have the public API or we want to use the API functions. We want to use request. I'm going to delete all of this, or maybe I'll use a new file. Let's create a new file. So now I want to say, I want to get all API users. Now, so instead of using local file like here, so I'm going to import JSON and import request. Let's do that here. Now I want to focus on the API URL and I want to get all of the users. So when you use this public API /users, you've seen all the users there. Okay. So if you want to see the documentation to see what you can do, you can just remove that and you go to the site here to see the different stuff. All right. So you have the different common resource. We have posts, comments, album, photos, to-dos. So you can say /to-dos, you see people put to-do list. You can put /comments, you see the list come out, we'll see /users, okay? You can do /photos. So you can use this URL to practice. All right. So let's use the users here. I want to return all of these API users that exist. Does everybody understand what I'm trying to achieve?
Yes.
So we'll create a function to get all of the API users. Now we looked at status code previously that we looked at the code that is 200, that is 404 and all of that. We want to always connect. When you're connecting to a public URL, you have to put the status code in mind. 200 is okay, successful, right? And anything that is not 200 is not successful. It's not the response you want. Let's just do that in this scenario. Let's say we want to get all API users, right? And here we'll use the request because request now is to connect to. We'll use the request module. You can use that to connect there. So now let's get a response from this URL here. So we'll say response will now be equal to request.get, and what we want to get is the API URL. We want to get, we put in the URL here, we already put where we are going to. Horizon, we want to ask the question. Type to ask the question. So I have a student who doesn't have a mic working, so the full extent of an API is limitless. You can create microservices. You can basically you are getting, updating, like with all the request methods we put. You can use it to even achieve interoperability, allow two systems to communicate. So most of the time, if you go to most advanced countries and you go to a doctor's office, their systems are always linked to the API of insurance companies. And so by the time you want to pay for something to see if your insurance covers and tell you what your deductible is. So you are linking that two systems are communicating. They don't need to call anybody to see what happens. Or they want to see the list of the system is connected to pharmacy, right? Like all pharmacies, and they will see the list of prescriptions. Maybe you have your social security number that you had to use or national ID before you get your medications. And they can just open the portal, put in your number, and it just downloads the list of all the medications that all pharmacies have given. It just communicates with all the systems. Right? There can be thousands of pharmacies, thousands of systems, but it pulls everything from everywhere. So the limit of API is like it's a powerhouse. It just makes systems to communicate. So it's almost like you have a letter, a mail system, you send a letter to somebody back and forth. That's what the API does, just go and get what you want. And if you want to update, it goes to update everywhere at once. Okay. So if you have your information, so the API, you can have your information in one place and you don't have to duplicate it everywhere and let other systems communicate to get that information. Let's say we'll use the hospital as an example again. You go to the clinic, they treat you, you don't like the way they're treating you, you don't know the medications they've given you, you discharge yourself, you go to a different hospital. They might ask you questions about where you have gone, what they have done, and all of that. And you might not be giving the accurate information. If the system in hospital A communicates with hospital B, they will see everything that was done there, everything that was entered there. So the API functionality is endless. It's the next generation of everything. So you can have internal tools in your company where you have an API that will link all your systems, where if they want to look at the list of, let's say, open vacancies, you just have an API that just has a list, so you don't have to build it in all your systems. So from any system, anybody logs in. Let's say we have students in School of Programming, you have in the other partner companies, and just one place, we just have an API for job listings. So all the other systems will just pull this for job listings, and instead of you now entering it in all the systems. So it prevents duplicate entry, it prevents mistakes, it prevents errors. You see things in real time. I don't have to send a message to my doctor to say insurance is no longer paying. They see it on their system when they log on in real time. When one person updates somewhere, other systems that communicate to see that it has been changed. All right. Does that answer your question, Horizon? Yes, you can use API to modify apps. So if they allow a post request, so some APIs only allow gets for you to get something. Some APIs allow you to update, like in the hospital team, for instance. Let's say the lab, you do a lab, work, and maybe at the lab is within the same hospital system, right? And you do a lab work And at the lab, they try to find your name, they don't see it. It is now so that your name has an error. That's why they cannot search. They put your last name for first, first for last. And then somebody in the lab updates your name. So all the internal systems within the hospital will have your name updated. So you can use that to modify the other apps. But those apps have to be in a place where they accept post requests from each other. But when you have a public API, except these ones we use for practice, modification is something that will be very hard, except if that API belongs to your company. Do you understand what I'm saying? Yes. Yeah, and the modification depends on the type of app also. So if you have an app and with public API and you want to update some values there, yes, you can allow updates depending on what is allowed. Yeah, you can also duplicate functions in APIs, but again, all of this thing depends on what app the reference is based on your app. All right. Does it make sense? So I'm going to activate my virtual environment again so that I will be able to um, get this request module. Okay. So now I want to use request.get and I put the public URL. So we'll say API URL. Okay, because now we already put /users here. That's what we want to connect to get all of the users. Now, when it's an API, if for instance the URL is wrong or it cannot, for some whatever reason, it cannot hit the URL or whatever, you want to say if the request module is something you want to read about. So you say if response. So what happens with the response is it gets it and saves it in this response variable. In the event that it does not find it, it saves the status code here instead. So if I try to hit an endpoint and it's not found 404, it's going to return something into this response, but it's going to be 404, not the data request. So you want to check the response and say if response dot, we have a status code method there. So if response dot status code is equal to 200, it means that the data was found. You always get, when you connect to a resource, you always get a status code from it. So if the response is 200, if we get 200 status code, it means everything is okay. We want to now return the response.json. Okay. But if the status code is not 200, anything else that is not 200, you want to print, let's just do basic and say we'll print API error. And then you return an empty list. Can you see what I've done here? Does it make sense?
Yes.
Yes.
So now if we say, well, let's run this. Let's say if name equal to main, we'll say get all API users. And let's run this and see. So we just have request.py and get all API users. Request.get status code, return response.json. Okay, we don't print anything. So let's say print. We only return. So let's print this. And so we run and we get all the users printed out. Can you see? So we have the ID one, see the list of everything printed out here because we printed out all. So it's working, connected to it, and we get all of the stuff on that place here. Does it make sense?
Yes.
So what if we
Yes.
want to get by ID? we have this thing we call path parameters. If we are going to do advanced Python course starting sometime in February, where we would deal with all of that. But we have the path in the URL. We have different path variables that we pass when we want to connect to an API. One of the things we did here is this one. Sometimes they'll say pass dot the user ID like this, but we want to put it in the function. We want to get users by ID. So let's say def get user by ID. So here we can use the input here to say user ID is equal to input, and we'll say enter user ID. Okay. And when the user enters the ID, we want to convert that ID to, well, we don't need to convert to an int because to pass it to the URL. That's what we want to do because it'll always be a string there. So let's say response will now be equal to request dot get, and we are getting the, let's use the format string here, and we'll say we want to pass in the API URL / the user ID that was passed in. You see how we'll do that? Because why we didn't put it here is we don't know in advance what the ID will be. So we want to make it like a variable that people will pass in. Okay. And then we want to now check the status code thing. If response, so it's the same thing we'll do here. If response to status code is 200, we want to return this. If not, we want to say user not found. Okay. So let's say if response dot status code is equal to 200, you will say return response.json, else return, let's say return, you can even return an empty list, or you say user not found. Normally you return this as a dictionary or as a list. Okay, let's return like this and see whether we'll have an error. And so we'll say get user by ID. Now let's look at the IDs we have here. We have an ID of, let's say I want to return 10, Clementina to Borg 10. So here we want to, let me clear here and run. The ID is 10, and we have a return, so everything is working fine. What if we enter an ID that doesn't exist? 1000. You said user not found. So you can see how it's easy to connect to an API, external API, and get what you want. So you can see that this helps you to answer your questions. So you can now use this to see if you want to filter by city. You can now enter the city. You use list comprehension or a loop like we did in this one to check all of the cities that are in the response that you get, or all of the address, you get the address and get the city from the address of all of the response you get, and then you get the user by the city. Okay, what if we want to save the API users to our file? And we have this save local data, but now we want to save to a file. And what we say we'll do here, we will save to a file called API users.json. I want to save this to a file. So let's try that and see. Let's see whether we can create a new one into the public API that we have there. And let's see whether we can update one that exists, and let's see whether we can delete one, so that you will understand how to do all of this. Okay, so we'll start with save to a file. Let's create a function. Def save API users to file. All right. And here you have users is equal to get all API users. Okay. We have the users. We could just call this to get all the users. We already have the function, and we want to open a file in write mode. So with open, we don't have the file, we'll create it. So we are going to open a file. We'll call it API users.json. Let's open this in write. I think we might have to create a file, but let's see whether this will create and append. Let's open this as file, and we say json.dump, and we're going to dump the users that we got here, and we will pass the file that we want to dump it in, and then let's put an indent equal to, let's use 4. Then when this is done successfully, we want to print, let's print here, API users, or let's say users added to local file. All right, so we have the local file API users.json. Another way you can do it is to put local file here, API users.json. Let's do that. API users.json, and here you just say local file. So you see that? Let's try this one and see if we need to create a file, or if the write mode will just create a file and write to it. So enter the user ID. Let's say we want, oh, sorry, I didn't change what I'm doing. So I'm going to do save API users to file is what I want to do. Okay. So I'll run this, and it's added it. So it created a file, see API users.json, and it puts everything that we have in the public URL into this file. Okay. Does it make sense?
Yes.
Okay.
Yeah.
So we know that when we want to create a new user, we've done an example for that in local file. It's the same thing, but here you use post request. So you want us to do that one, or we should go to the update where we try to use the put request to update. So request method is very straightforward. If you use this request module, so here if you want to add something, it's going to be post. If you want to update, it's going to be put. And if you want to delete, it's going to be delete. Okay, so I think that will cover it all. If I do those parts for you, it's like I've already answered all your assignment questions, and I really want you to be able to activate your thinking in those ones. All right. So do you think you've answered, you have a better understanding of API and JSON?
Yeah.
Yes.
Yeah.
Okay. Everybody, anyone has questions when you go through it? Okay. So, is there anything I should go through again? So we can quickly introduce week 12, where we talked about adding weight to the graph data structure. We are looking at the weighted structure. And we look at the different algorithms in the pre-recorded videos that we use. In week 13, we're going to look at the minimum spanning tree, which will tie up into everything that we are doing. So I will not go into details now. I'll just give you an example of what we are going to do, and probably we'll do it either on Monday or Tuesday morning, so we can combine week 12 and 13 together. So, or maybe we'll just have the live class on. I'll let you guys know by Monday for the week 12, and so we'll combine week 12 and 13, which will guide you in your assignment 9. All right. Well, we want to have a city emergency response network. And what we want to have is a hospital. We'll use H to denote hospital. We have police station, P. We have fire station, we'll call it F. Rescue centers, we'll have 2 rescue centers. Let's say we have rescue center 1, rescue center 2, and we want to have a emergency helipad, and we'll call that E, like this. So this will be the different codes we want to use, and these are going to be our network nodes. Nodes are just the different parts. What we want to achieve is we want to know the time in minutes from the hospital to a police station. What is the time? From the hospital to rescue center 1, okay? From P, the police station, to the fire station. From the rescue center 1 to the fire station. From the fire station to rescue center 2. From rescue center 2 to the emergency helipad. All right. From the emergency helipad to the hospital. And from the police station to the rescue center 2. Now, this is the scenario we are using. You can make up one in your mind to say all you want to know is you are building it for a fire station. We want to see the distance from the fire station to all other places, to hospital, to police station, to the rescue center 1, rescue center 2, to the emergency helipad, right? But we just do the scenario so that we can illustrate everything that we learn in weighted graph. So I want you to understand week 11 and 12 in details before we meet, and we'll try to build this app that we will use to do an emergency response system for a city, right? Now, when we look at this, we talk about circle detection, and I want you to go back and watch a pre-recorded video to understand why we even try to detect circle in the first place. When there is a circle detected, then we will have paths with high vehicle traffic. We're going to have different things will occur. And maybe you don't want a circle detected. You want to have a system where you want to find if a circle has been detected, if it's not detected, and why do we do that? Let's look at this. We can go from hospital to the police station. We can go from the hospital to rescue center 1. So those are the 2 places we can go to directly from the hospital. We can go from the police station to the fire station, from the rescue center 1 to the fire station. And these are the 2 we can get directly to the fire station from the police station and the rescue center 1. From the fire station, we can go to rescue center 2. From the rescue center 2, we can go to the emergency helipad. So if you want to go from rescue center 1 to emergency helipad, you can go from rescue center 1 to the fire station. From the fire station, you stop at the rescue center 2, and then from rescue center 2, you get there. From the emergency helipad, you can get to the hospital. And from the police station, you can get to rescue center 2. So looking at this, can anybody see the circle?
Yes.
So where's the circle?
It's 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 just I can't pinpoint the exact starting location, but I see it's going round and
Yeah.
I'm still trying to connect.
Okay, so now we can see you start from the hospital here and you can get to the hospital here, right? So you have hospital on this side, you have hospital on this side. Let's start with hospital. How do you get from hospital to hospital in a circle? If you come from the hospital and you go to, let's say you want to get from hospital to rescue center 1 here, you get to rescue center 1. From rescue center 1, you can get to the fire station. From the fire station, you can get to rescue center 2. From rescue center 2, you can get to the emergency helipad. From there, you can get back to hospital. So you can see the circle. You follow a route and brings you back to the place. So assuming you want to get to um, the fire station from the hospital, when you get to rescue center 1, you go to the fire station. But assuming you want to go back from that fire station to the hospital, you have to go through rescue center 2, emergency helipad, the hospital, right? But you can have another route to go there. So what we'll do is we'll calculate the shortest path, look at all the circles that we have. Let's look at another circle. Let's see if we have another circle. Let's look at the police station. From the police station, you can get to the fire station. From the fire station, you can get to rescue center 2. So you can see that after this police station, there is no other police station down. So how do you know a cycle is detected at first glance? When you see below, after this hospital, on this right side, is there any hospital below here? Yes, that means there's a circle. When I get to P here, is there any P beneath this, after this line, on the opposite line? No. So there will be no circle. In R1, is there any R1 here beneath this row after? No. F, no, beneath this. R2, yes, there's a thing between R2 beneath this. So where will you get a circle from R2? From R2, the rescue center 2, you get to the emergency helipad. From there, you get to the hospital. But why the circle is not detected here is there is no path from the hospital to the rescue center 2. So you cannot get from rescue center 2 to rescue center 2. Do you understand?
Yes,
Yes.
yeah.
Yeah, so I want you to observe this, take a screenshot, take a photo of this, and meditate on it until we meet. And we'll do both minimum spanning tree for week 13 and week 12 together. And we're going to try to look for a way using this app that we will deeply understand the graph data structure and use this in our next life lesson. I'll between Monday and Wednesday, we'll have the class. I'll let you know on Monday when that class will hold. Okay. And then let's say a road is closed because of construction or broken. Are we going to remove that broken road? What is the edge where the road is? You understand, to remove. How can we do like a GPS to add real-time traffic if there's a lot of traffic on the road and there's a delay? So an emergency vehicle like the fire station has different paths to get to the fire station from a location. How will the fire station see the shortest path? How will they know this path is blocked and let's not pass there? Something like that. So we'll try to um, create all of this in our next class. Okay. So anyone with a question?
No.
No.
All right. In the absence of question, so see you all next week and have a wonderful weekend.
Thank you. Bye.
Thank you. See you.
Bye.
Thank you.